Hello everyone, this is the fourth video of topic 2.2, bonding between atoms. We'll continue to look at the ionic bonding. I'm looking at slide 17 and now 18. Now in the previous video, I mentioned that I will look at the properties of ionic compounds, which is in the third box down there. Can be explained using the model for ionic bonding. Now we'll look at that because I ran out of time in the last video. Okay, so the slide that I would like to go is slide 28. Only a few slides are covered. The one with the salt crystal and molecular size, the zoomed in version of that compound. Yes, ionic compound. All right, so a structure of ionic substance. Now, if you remember, they can be big. They are large lattice structure. The electron transfer occurs between atoms. If you are looking at elements losing or gaining electron to be an ion, they would have the electrostatic charge. So charge will stay as positive or negative permanently. This creates many cations and anions, because if you have got a chunk of sodium and chlorine gas, you wouldn't be just looking at one atom of each. It happens in a big cloud. So you would have a lot of cations and anions being created. When that happens, they arrange into this regular repeating pattern. And if you remember that, I already mentioned that, but you call that as lattice. In ionic bonding's case, it's called 3D crystal-like lattice, or just simply ionic lattice. Okay. If you look at the molecular structure, so Na and Cl repeated at this zoomed in version, what shape is this in? It's 3D. It's cubic shape. If you keep extending that, what would you get? You get a cubic shape crystal of NaCl. So if you know how ions are bonded to each other, you can also see that in the shape of crystal of any salt. Now, when I say salt, I'm using the term chemical term of salt. It just means ionically bonded substances, ionic compounds. Any ionic compounds are called ionic salt in chemistry, not only NaCl. All right, moving on. So by knowing the structure, what can you tell? What sort of properties are there for it? Now, firstly, it would dissolve in water. Now, everyone should know that NaCl dissolves in water. That makes up 70% of the Earth. Why does it happen? There's a diagram there. I'll zoom in again. So Na and Cl, positively charged and negatively charged ions, they can be attracted by water. Oxygen part of the water is negatively charged as well. So that's more electronegative compared to hydrogen. So oxygen would try to attract the positively charged ion, and at the end, the positively charged ions are surrounded by water molecule, and all the oxygen is facing towards the positively charged ion. On the other hand, because oxygen in water molecule are more electronegative, that creates more of the exposed positive end of hydrogen, because hydrogen has only one proton and one electron. If electron is facing towards oxygen, then proton would be exposed, which means it would start attracting negatively charged things like chloride ion. When that happens, it would be the water molecules, hydrogen parts would be attracting and surrounding the negatively charged ion. Hence, you would see ionic compound being able to dissolve in water. And that's another diagram there too. Oh, by the way, you need to be able to explain why. You need to be able to explain why this happens. So if you have written down my explanation just then, that will be just fine. Secondly, you would have noticed from the experiment you did the other day that ionic salt, they don't conduct electricity. Why? Look at the structure again. Na and Cl. Would they move at all? Na plus and Cl minus, I should have said. Ions don't move in solid because they are so tightly bonded to each other or attracting each other. Say 6 volts, 2 volts that you use is not good enough to delocalize. If it's in liquid state, on the other hand, so if you could heat up high enough, like 1300 degrees, you can start having conductivity in NaCl even, but it needs to be liquefied. So at liquid state, they can. When it dissolves though, you can see that electricity is being conducted. Why? Because ions are delocalized. Ions are free to move. Ions act as charge carrier. That's what causes the electricity conductivity, electrical conductivity in dissolved salt. They would have high melting points. Like I just mentioned, NaCl has melting point of, I think, 1200 to 1300, fairly high melting point. Why? Because you would need to separate the bonding, and breaking bonds requires energy. You have to put a lot of energy to break the bond. Okay? So ionic compounds would usually have high melting points. Okay? This is where I would stop because you can do now questions in a Essentials workbook. All right, I'll see you in the next video.